we're going to start chapter 5. Everything that we've looked at prior to today has, not everything, but most of it has been linear. Meaning everything makes a straight line, right? Everything that's linear makes a straight line. Quadratic functions. You guys see that okay? Chapter 5 is all about quadratic functions. You did learn about this in Algebra 1. This should be a small review for some of this. Some of this is going to be new. But quadratic functions all make a parabola. And that is what we describe that shape as. That U shape is called a parabola. In this first section, we're going to graph parabolas. In order to graph a parabola, there's some things that you're going to need to know. First of all, how do you know that something is quadratic? When we looked at linear functions, we just knew it was linear because of the slope-intercept form, or it was a standard form, right? If it's quadratic, there's something we're looking for, so we know that it is quadratic. And that's an exponent of 2. If we have a term or a variable that has an exponent of 2, then we have a quadratic function. If it has an exponent of 3, is it quadratic? The exponent of 4. If it doesn't have an exponent other than maybe a 1 or no exponent at all, is it quadratic? No, it has to have an exponent of 2. And this is what we call the standard form for quadratic functions. You know, linear functions have standard form too. That's ax plus by equals c. This is the standard form for quadratics. So, recognize it as quadratic, number 1. That's how we're going to know that we're going to graph it as a quadratic. Second thing, we know our graph is all going to be that of a parabola. So we've got our mind as quadratic. We know what the shape, the basic shape is going to look like. Now, there's some things that you're going to have to know about this shape. You guys know what a vertex is. We've talked about that with absolute value graphs. The vertex is that bottom point of your graph, in our case of our parabola. We're going to find that vertex. We're going to find a y-intercept, which is where our parabola is going to cross our y-axis. We're going to find an axis of symmetry. Okay, we're going to find an axis of symmetry. You guys know what a line of symmetry is. Probably back in middle school, or if you're in geometry, we talked about symmetry before. That's an imaginary line you could draw down a symmetrical shape, where if you fold it in half, it's the same thing on both sides. Parabolas have that line of symmetry, and it's called an axis of symmetry. We're also going to plot and graph a reflection of our y-intercept. And we're reflecting this point across. Our y-intercept, we're reflecting it across our axis of symmetry. So how do we find all those things? Well, we're going to use some formulas. We're going to use some formulas. For the y-intercept, we're going to either let x equal 0, or we're going to use the cover-up method. We're either going to let x equal 0 or use the cover-up method. I could write this on your paper, guys. You have 4 graphs. We're probably not going to get through all 4 of them together or today. So next to, let's see, next to y-intercept, let's write that down. On the first graph, down below it has y-intercept. Write down that we're going to let x equal 0, or we could use that says cover-up method to find our y-intercept. The next thing on your paper says axis of symmetry. There's a formula for finding our axis of symmetry, and it's right here. The axis of symmetry is an equation. You will always write this as an equation. I don't want 6 or 1/2. I want your axis of symmetry written as an equation. X equals 6. X equals 1/2. Whatever the case is. But it does need to be an equation. And this is read the opposite of b divided by 2a. Now for the vertex. Technically, this is the formula for a vertex, and it is above the door. Okay, so worst case scenario, I ask you to find the vertex and you can't remember how I told you, there's always a formula up there above the door. That will always find your vertex. I'm going to show you what I feel is a little bit of an easier way to find your vertex. copy this down next to vertex so you will have that formula, but we're going to alter that just a little bit when we find our vertex. Now, in order to graph a parabola, we're going to have to find each of these things. When you're graphing, I want you to have a clear dot or a clear line, symmetry, where each of these points are. These are going to help form your parabola. We call these critical points on our graph because they help us see the big picture. They help us to graph very easily. Does everyone have this copy down where they need it in their notes? Alright, so we're going to graph, we're going to walk through this together, so you don't really need to write that down. Here's the first example. So on the front of your paper, on the left-hand side, you probably have that all filled in with information, right? Let's use the right-hand side to do the first example. It says below the graph, f of x, copy down what f of x equals, x squared plus, I don't have two hands, so I'm just going to use a couple of blocks here. I'm going to cover up those x terms. What do I have left when I cover up those x terms? There's your y-intercept. Now, just like on our test, how do we write intercepts? As an ordered pair, and I need it as an ordered pair. It's incorrect, guys. It's not -2. It's 0, -2. It's a point on our graph. 0, -2. And the next thing that we need to find is our axis of symmetry. And I like to abbreviate that a little bit. Abbreviate AOS, axis of symmetry. And remember, there's a formula for that. X equals the opposite of B divided by 2A. Okay, so you're probably like, well, what's A, B, and C? You remember I told you the standard form for a quadratic function? We looked at that a few minutes ago. That looked like this. It was actually y equals ax squared plus bx plus c. A, b, and c are our coefficients and our constant. What would a be in our case? What's in front of x squared? 1. What's b? 6. And c are constant? It's -2. If we know what a, b, and c are, we can easily find our axis of symmetry. Really, we only need a and b. So to fill into your equation here, we have x equals, it's always an equation. This is the opposite of b. So if b is 6, the opposite of that is -6 divided by 2a. 2 times 1. So -6 divided by 2. Don't just say -3. Your axis of symmetry is an equation. We're going to graph this, graph a line, x equals -3. Want some good news? We just found our x-coordinate of our vertex. We just found the x-coordinate of our vertex. This value right here is -3. Now, remember for our vertex, I said you could use that big, it's pretty ugly formula, isn't it? It doesn't look, not too bad, but it's just a matter of plugging in. But there's the easier way. We have the x value of our vertex right here. X is -3. If we plug -3 back into our function, that's going to give us our y value of our vertex. And that's what we're going to do next. Find our vertex. I'm going to find f of -3. I'm going to put -3 back into my function and solve. So -3 squared is 9. 6 times -3 is -18 minus 2. 9 minus 18 is -9, and -9 minus 2 is -11. Now think about what you know about what a vertex is. Isn't a vertex a point? So our answer needs to be written as a point, as an ordered pair. Well, what is the x-coordinate of our ordered pair? -3, that's what we put in for x. What's our y-coordinate of our ordered pair? -11. I like to find my vertex this way. If you're kind of a formula junkie and you like to use that formula, by all means you can use that formula. I just feel like there's less of a chance of making a mistake. You plug it back in rather than if you start over and use that formula. And in that formula, the opposite of b divided by 2a, that's your x-coordinate. Didn't we just find that opposite of b divided by 2a? We found that when we did our axis of symmetry, didn't we? Okay. And the y-coordinate is 4ac minus b squared all divided by 4a. You'll get the same thing if you had done it our way or the formula way. You'll get the same value. Alright, at this point, we're ready to graph. We're going to need to put each of these three things on our graph, and it really doesn't matter which one you do first. You guys have a graph already set up. First, I'm going to start with my vertex, -3, -11. Now, remember that axis of symmetry, it goes through your vertex. So if you ever have an axis of symmetry that doesn't go through your vertex, something's up. It should always go through your vertex. Our axis of symmetry is at x equals -3. That's going to be a vertical line, up and down line, at -3. And we use a dashed line because it's really not a physical part of our graph. It's more of a guideline for us to use when we're graphing. So use a dashed line for that if you would. Our y-intercept is at 0, -2. Now, you're probably thinking that really doesn't look like a parabola. We need to have one more point, and we call that other point our reflection point. I'm going to take this y-intercept, this one right here, and I'm going to reflect it across that axis of symmetry. So pick it up and put it across your axis of symmetry. That's going to put us a point right here at -5, -2. Now that I have those 3 points and I've got my axis of symmetry, I should be able to sketch in our parabola. This is not a V, it needs to have a curve, a U shape. Is your graph look like my graph? Put arrows on the end to show that that parabola does keep going. Now, these points are not always going to be nice, perfect numbers. They may be decimals. You guys can handle that. I'm okay with decimals on these. The big thing I want you to make sure you do, we need 2 ordered pairs, 2 points. We have a y-intercept and a vertex, both of which are written as an ordered pair. And the axis of symmetry is an equation. I will mark it incorrect if they're not written appropriately. So make sure you remember that. 2 ordered pairs, 1 equation. 2 ordered pairs and 1 equation. 2 ordered pairs, 1 equation. Let's go to another example. Let's try another one together. We have f of x equals x squared plus 4x minus 3. Go ahead and copy this down. You'll have to flip it over to the back side of your notes. Like we said in the last one, there's 3 things we have to have to find. And it really doesn't matter what you find, except I would find the axis of symmetry way before I find my vertex. Well, let's start with the y-intercept. That's the cover-up method. That's when I said cover up those x terms. So if you take and you cover up those x terms, what do you have left? -3. Now remember, a y-intercept is a point on your graph. So we write our answer as an ordered pair. 0, -3. We need to find our axis of symmetry before we do a vertex because we need that value of our axis of symmetry to help us find the y-coordinate of the vertex. So let's do axis of symmetry next, and again I abbreviate that AOS just to save some time here. The axis of symmetry is a formula, it's an equation. X equals the opposite of b divided by 2a. And if it helps, you write your standard form below your function. So it's the opposite of b divided by 2a. In our case, what's b? 4. So the opposite of b is -4 divided by 2 times a. And a is a number in front of x squared, which is 1. In our denominator, we have 2 times 1. So -4 divided by 2 is -2. Remember, the axis of symmetry is an equation. I want you to rewrite this. Write this as x equals -2. Make sure that your answer is clearly an equation. X equals -2. Now we're ready to find our vertex. So to find our vertex, we take the value that we use for the axis of symmetry and plug it into our function for x. We're going to find f of -2. -2 squared is -2 times -2, which is 4. And 4 times -2, -8 minus 3. 4 plus a -8, -4, and -4 minus 3, -7. Remember, the vertex, like the y-intercept, is an ordered pair, so your answer needs to be written as such. The x-coordinate of our ordered pair is what we found x to be, -2, and the y-coordinate is -7. So we have our 2 ordered pairs, or 2 points, and we have in our equation, we have enough information that we can graph this parabola. Let's start with our y-intercept, -2, -7. -2, -7. Our y-intercept is 0, -3, and like I said before, it doesn't matter what order you graph this stuff in. It really doesn't. As long as you have all 3 here in your graph. Now, our axis of symmetry is an equation. It's x equals -2, so it's going to be a vertical line at -2. Now, we need one other thing. Does anybody remember how we found that third point? Good. Reflection point. Take your y-intercept and reflect it across your axis of symmetry. So it looks like it's going to be at -4, -3. Now we have enough information we can sketch in our graph. And like I said, they won't always be nice points. As far as the ordered pairs aren't always going to be integers. They may be fractions, that's okay. It's still working with them. And like I said, I'm okay with decimals on these. Guys, this is it. This is what we're doing today. We're practicing graphing these quadratics. There's 3 things we have to find. What is one thing? Somebody raise their hand and tell me one thing. Logan, sorry.
Vertex.
The vertex. And remember, we find the vertex how? Can you tell me how we find the vertex? Okay, how do you find that ordered pair? We use the value of the axis of symmetry and plug it back into our function to find our y-coordinate, don't we? Okay, so our vertex is the first thing we need, or one thing we need to have. What's another thing? The y-intercept. And how do we find that y-intercept? Evan, how do we find the y-intercept? Do you remember? Evan, to find the y-intercepts, we're going to use the cover-up method. Cover up those x terms. Okay, find that y value. So we have a vertex, we have a y-intercept, there's a third value. Do you remember what that third value is that we have to have? The axis of symmetry, and that's the equation. What is that equation, Megan Bezos? The opposite of b divided by 2a. Remember, that value, that x value you find on your axis of symmetry is what we're plugging back in to find the y value of our vertex. I'm going to to stop here because I want you guys to get a stump on your homework. Tomorrow we are going to move on to something new, so it's important you guys have it completed tomorrow. So we can add on to this. Alright, your assignment is going to be out of your book. And I'll rewrite it over here. It is on page 254. Yes. 5 through 6. 18 through 21. And I do have graph paper for you. I don't want you to have to do this by hand, excuse me. On the assignment, or the graph paper you're going to use, I've written out y-intercept, axis symmetry, and vertex, so it's kind of foolproof. You know, those are the 3 things you have to have to make sure you find each of those things. Down page 254, 5 through 6, 18, 21.